Thank you very much for attending. For those of you who attended last session 2 weeks ago, that's great. If you didn't, that's fine too. We're not going to talk about anything that you're going to be missing out if you didn't attend the session last time. A little bit about me. I'm a data platform MVP. I live in Arizona, so hence the desert isle. And if you have any questions after the session, you might want to reach out to me on Twitter, or there's my contact information. Okay, so let's talk a little bit more about data lakes and virtual databases. So anymore, many people have all sorts of data that they're storing, and they putting it into a data lake is a great way to ensure that your data is in a safe, secure location. And that's kind of a new space, because once it's there, then what you can do with it is you can choose to join the data together. But the step one is basically, make a virtual junk drawer where you toss everything and then figure out what you're going to be doing with it. Of course, there's a way to organize this so that you don't have an issue where you've got that exploding closet thing going on that you can never find anything. So we'll talk about how to organize and how to join data. And then we'll get into curated data. So once you've got your data that is organized in a fashion that can be helpful for reporting, then it's considered curated. You may decide to create several different data marts with your curated data, but their data is going to be in a flat file. And you can use a CSV file. We'll talk about some different file formats and their different advantages and disadvantages. And then we'll look at how to query the files in place. I know everyone thinks, well, I have data, I need a database. Well, yes, but as we know, databases, if we're putting them in the cloud, do have some kind of significant costs and maintenance that are associated with them. And you may be able to get away with not having a database, but still being able to use SQL Server Management Studio to query your files. So we'll take a look at how we do that. All right, so generally speaking, the first thing you want to do is identify what are your source systems. Obviously, if you're taking data from your current applications, that's a source system. Maybe you're gathering data from third parties. Maybe you've got a customer or a client that routinely sends your data, or you have a hosted system and you extract data from it on a periodic basis. Maybe you've got department-specific data. Maybe somebody is updating Excel spreadsheets that's the only place that information exists, and it's important to your business. And then there may be publicly available data that you might wish to include. I know that different companies are looking at doing things like the rates for different currencies, which they get from the web on a daily basis, or perhaps it's something like the current interest rates if you're doing mortgages, so to see how the difference in what the prime rate is affects business. I've even worked with a concrete company that went and got weather because nobody buys concrete when it rains, and that impacts their business. So you could have all of this different data that will be important to create a full-on picture of what's going on in your environment. So figure out what kind of data you have. Again, this can be Excel spreadsheets. This can be CSV files. It can be, you might want to decide that this is a place that you're going to put your database backups as well. So, and the database backups could be not something you're ever going to use necessarily to do anything, but have it as a storage location. You may decide to put up videos that you have from your security system. All sorts of things that you could possibly include as your source systems. Now, once you know, hey, this is the data, I want this to be the data that I'm going to be using within my environment, then how are you going to get that data up to the cloud so that you can have it in a central location? Well, if you just want to look at something and just kind of make it available to your entire organization, you may just want to put it up with the Microsoft Storage Explorer. So the Storage Explorer allows you to just paste up a file to your Azure Data Lake Gen 2. And then you can take a look at how that data compares with other data you might have. It's a great place to share it with people. And of course, you can add security to the folders to only let associated users access the data that you're looking at. But if it's a small ad hoc process, that's one thing. But let's say that you get files every Tuesday that you want to, from your vendor that you want to start using in analysis. Well, you're probably going to want to create an automated import process. And that you'll also want to do that, say, if you want to take extracts or maybe your entire source system and put it into a centralized location so that it can be used as a data warehouse. In that case, you're probably going to want to look at a self-hosted integration runtime. And that's ideal for when you've got data on your local servers and you want to migrate it to the cloud. So any data that you have, anybody sends you, if it's not cloud-based, you're going to be implementing a self-hosted integration runtime and then an integration job, which will take that data and migrate it to the cloud and then process the data so that you can start using it. So again, there's two different ways that you can use to load data if you're talking about using Azure-based tools to do it. And these are both using a tool that is called Azure Data Factory. And Azure Data Factory is the SSIS for the cloud, for lack of a better way of describing it. So it's a way of migrating your data and then manipulating your data. Well, if you want to make it really easy on yourself and you want code that many people will be able to not only read, but maintain and take a look at what's going on, you've got you can write it all using data flows. And data flow is a low code solution. It's the clicky and draggy method of doing it's commonly called extract, transfer, and load, but some people call it extract, load, and transform because that's really the order that you do it in a cloud-based environment where you were just basically extracting it from somewhere and you're loading it. So with a data flow process, it's going to be a little bit higher Azure cost because it's easier to do. And kind of by that trade-off there. If you're using Azure Synapse, and we'll take a look at these different solutions so that we know what I'm talking about here, then you can write code to load the data so that you don't have to use the higher cost data flow option. So, but of course, there's caveats to that as well, because while it's lower to run, it's perhaps a little bit higher development and maintenance costs associated with it. So keep that in mind when you are trying to determine how and what tools you're going to use to do that. So with the self-hosted integration runtime, that's the application that you're going to need to install to send data to the cloud. This is something that you would install on a server class machine that you've got locally. And it's also used for Azure ML, but it's not the same as a Power BI gateway, even though it does the same thing. Those teams just couldn't get together and get one gateway going. It works the same way if you're familiar with a Power BI gateway, in that you schedule the data to be pulled, and then it uses this application to basically create a secure tunnel, allowing you to transfer data from local to the cloud. You do need to assign security to this, so that and assign a user to do that who's got rights to the different areas where your data is loaded locally to be able to run this job. But it's very similar to a Power BI gateway, but not the same application. And it's not recommended to install them on the same machine. They can cause conflicts with one another, unfortunately. So when I'm talking about putting things to a data lake, what I'm talking about is an Azure Data Lake Gen 2. And this is a type of storage that I'm commonly referring to as a data lake. It's a long-term data storage solution. It's relatively inexpensive. And it can also be used for many things. You can use it as a backup location as well. It's just basically a giant file structure in the sky. The difference between the Gen 2 part is they added folders, which of course is very handy if you're trying to organize up your data lake. And of course we are, because we want to be able to find things after we have place them into the cloud. And this is going to be the source for our virtual database. So we are going to take the files that we are creating here, and we're going to query them as if they were in a database, because we're going to make them act like that. So what kind of data can we put in here? Well, we can have structured data, and that would be anything with columns and rows in it. That's what it means by tabular data. CSV, text. You can have things that are more loosely structured, like XML, JSON, and even things that are more exotic, like Parquet and Mongo as well. So any kind of structured data, but you can also use unstructured data. You can use your data lake to store, say, images. If people are sending you documents on their phones as pictures, you can save those. Sound files. So if you have recordings that you have for different meetings and you want to keep them all into a standard location rather than having to run around Teams and find out where they are, then you can store those up in the cloud as well. A lot of reasons that people do this is because they want to find things. And there are a number of different tools that we're not going to go into today, but the book that I wrote talks about more of them, where we use cognitive services to help you sort through and find different things as well. So if you have them in a storage location, or you can be nice and index them as you go in so that you know what's in there. But a lot of times you don't know. So you can put your images in there, run a process to identify, oh, this is a registration card, and this is a picture of that wrecked car for, say, an insurance company. You can put in PDFs, any kind of signed documents that perhaps you've got lying around, or just Word docs, any kind of document that you happen to have, whether it be Word or Open Office, put them in a central location. So think about this as kind of what you might have as a giant SharePoint site that you might have somewhere. Now, of course, we want this to be a structured location for you're storing all of your data. So a common way that people are starting to refer to this is they're calling it a data lakehouse. And a data lakehouse is when you start using a data lake as a data warehouse. Now, you definitely can do this, and I'll actually show you how to do this. And by doing this, you're structuring your flat file data as if it's in a warehouse. You can choose to load the data to a data warehouse if you want. Your data warehouse could be the classic Azure dedicated SQL pool, or you might do it to a SQL server, depending on how much data you've got. It needs to be well organized to be able to do this. In our next session, we're going to be talking about the fact that if you don't have a ton of data, your data lakehouse could be the place that you have the data model that you load into Power BI. So, and you can use that as a virtual data warehouse that you have within a Power BI model. So you've got a number of different ways that you can organize up your data to make it useful for you. And also, it's really flexible. Let's say that you decide that you just want to do a proof of concept. You want to organize up your data. You want to get it in a central location so it's possible to, say, start writing reports off of it. And then you decide, hey, this is really cool. Let's open this up to maybe allowing people to do ad hoc queries. And maybe we want to, so maybe we'll add a database to it. And if you do, that's no big deal. It's just a very simple process to migrate it from files to a database, should you wish to do that. And mind you, you can, once the data is well organized, it's not a big deal to do it. You can even hop clouds if you want to, and load that data to, say, Amazon Redshift, if you want to load the data there, because the most complex part of getting a data lakehouse, which is the same as getting a data warehouse to work, is that you need to make sure that you have formatted the data in a way that you can join it all together. So that's definitely the interesting part that is going to take the most time, and is going to require a lot of business knowledge to know which the appropriate elements to include and join together. So I do want to say, though, if you do use this data lakehouse solution and you decide that you want to do a lot of ad hoc querying on your data, it's not going to be as fast as a data warehouse or a database because it's files. But does that matter? Do you care? What are you doing with it? Because sometimes it really doesn't matter. Again, if you're using it to back into Power BI, totally doesn't matter. If you're using to connect to, say, SSRS, maybe you find the speed acceptable. You can do a number of different things with it, and you may find that it does what you need, but don't expect it to be super fast. And unlike a database, there's some tuning you can do, but it's never going to be super duper fast. But if you decide you need that speed, hey, it's not that big of a deal to add a database to it, improving the speed. So let's talk about how you would set up your data lake so that it is your storage solution. So there's a couple of different methodologies. This is the classic, if you will. This is the one that's been around the longest. It's basically bronze, silver, and gold. And most of this I agree with, but I kind of tweak it up a little bit. But I'm anticipating that you'll probably have separate storage accounts for different environments. Now, you may not, because raw data is indeed raw data. So you may decide, I don't need a dev raw data. I just need raw data. And maybe you have an area in your raw data area that you might test your data load, possibly. You could do that as well. Or you could basically say, look, we're going to make this like real production and have a different account for dev, test, and prod. Now, these also have different levels of security. For your raw data, that is an area that you want to set up so that it is only write, and certain accounts can write to it, and then other people can read to it. Otherwise, no modding. And the reason is that this is called raw. And it's supposed to be called raw for a reason. You don't want people to change your source data because you may need to go back to it someday. One of the things that's great about this kind of solution is it supports different kinds of environments. For example, let's say that you just right now are only interested in creating a data warehouse-like structure using a data lakehouse because you want to do reporting and analysis on it. But you also want the ability to say, have the data in a format that a data scientist might go through and analyze your data and do maybe some predictive analysis on it. Data scientists don't really like warehouses because it excludes things and summarize things. So they're always looking for the raw data anyway. So having the raw data can be really helpful if you want to do different kinds of analysis later on. So always have raw data that's not messed with. And then if you do decide that you need to modify it a little bit, that would be where you would have it in your silver area. So here you might also say add different elements, like, for example, let's say that you wanted to add all of the ISO codes for countries so that you could make sure that you had the right ones. But 3-digit versus 4-digit, stuff like that. This is where you might start joining things if you want to do a phase join where you join two things, then you add something to it. This would be where your work area would be. And the last area is where you will have people report on it. So this is going to be report ready. And this is going to be something that people are just reading from it. Again, it's very similar to the raw data area in that this is a location where people are just going to go to query it. And this is where our virtual database is going to be, in the gold area. Now, kind of blowing out this logic, I tend to do something more like this because it handles more solutions. A lot of times I don't want to keep the raw data in one place forever because it starts clogging things up. And I'm always kind of looking to be economical minded when it comes to looking at cloud spend. I can, if it's raw data, I might want to do like a hot backup synchronously located storage. But for archive, well, I don't really look at that often. So if it takes me a while to get it back, I don't know how important that is. So I might put that on just like a local storage area, making it cheaper. So just moving things over there that aren't, I want them around, but I don't need to access them that quickly. And if it takes longer for me to get them back, I'm okay. So adding that archive will provide me with that. So I'll probably move raw to archive on a periodic basis. Now, the structured data would be where I'd have my kind of an intermediate area, as well as with stage. Reference, might be where I would add a date table, maybe add my holiday list, any kind of reference data that I might need that I want to include, I might include in my reference area. And again, curated is the same as the gold area. This is where I'm going to have my data lakehouse that I'm going to use for structured querying. So in these, within the different file folders, you might have other areas. You might have within your raw, you might have an ERP system. You might have third-party files that you received. So different data sources and different feeds, have those in folders, and then partition them based on date. Maybe you've got a 2022 folder. Within that, depending on the frequency of how often you get data, you might have months, and you organize them that way within your subsystems. You might also have a sandbox for user development, so people can screw around and do stuff that nobody else has to deal with. So some other ways that you're probably going to want to organize up your data lake, especially if you have data scientists, you want to give them the ability to create a sandbox area, perhaps someplace in this in the stage, not on raw, so that people have the ability to play around, manipulate data, take a look at it, do some things that may or may not be ending up at any kind of development, but just basically a play area. So of course, we want to apply security to our different folders. So these are done through Azure role assignments, and they are going to limit storage to different owners. So with these, it's basically based on AD permissions. And so your AD permissions ensure that, not everybody can see all of the data if that's not appropriate. And you want to provide access to service principals. Now, when I was earlier talking about different storage partitions, I'm talking about a file folder structures like this. So this is optimal also for folder security. Maybe I don't want people to see data for different years because they don't need it. So I'd have my subject area, maybe I'd have my ERP system here and then I might say that this came from, or might have the subject area might be SQL Server. And then my different databases that I pull off of SQL Server. And then the different year, month, day, and then the files. So if I get a bunch of files in a different day, then I've got them in these different folders, making them easy to find and easy to query as well. So in terms of what kind of data that I'm going to have in my raw area or in my curated area, I've listed some common storage formats. CSV is probably the one that you are most familiar with. It's human readable. It's what Excel turns into. You could also have Excel too. I didn't put it up here, but it's certainly acceptable. There's no reason to migrate from Excel to CSV. You can just keep it in Excel. There's no point in translating it. And less work, and we're all about less work. And then a Parquet folder is a file folder. It's a folder structure that is designed for long-term storage. It's compressed. It's also not human readable, so that you can't see what the data is. You can read it in Power BI. There are different tools that can read it, but you can do it. And I said that you can use Excel too, but Excel is not as common as CSV. But hey, I would not change the format of Excel at all. Excel is just fine as well, especially if you're talking about raw data. And of course, there's no reason to convert any file that you get, that somebody sends to you. First, you put it in there as you got it. So if you got a giant Access database or Excel file, hey, just put that up into raw just the way you got it. You want to modify it after it has been there. So don't change it. And of course, put in Excel if you have Excel files. Now, that would be more in your raw area where you'd have your Excel files, you'd have Access databases. But when you're looking to do more long-term storage, improve the querying, that's when you'd want to migrate to something like a Parquet structure or a Delta Lake structure. So the Parquet files are designed for Spark processing, then they're designed for fast querying. And they're part of Apache Hadoop, which is why they've got a dumb name, because they're all about that. And with this, it helps with your long-term storage because it takes the data and compresses it. And it's about 30% compression compared to a CSV file. So it's something that you're probably going to want to keep your files in for long-term storage. The other thing that you might want to do is once you have them in Parquet, you can create a Delta Lake structure on top of it. And the Delta Lake will allow you to treat your files even more like a database. And it's an open source data layer that's built on Parquet. And basically it brings ACID transactions. So just like a database, remember that's atomicity, consistency, isolation, and durability. So bringing those ACID transactions to your larger data elements. If you want to create a virtual database, it's also great because it'll do what they call time traveling and the rest of us call backups. So you can look at the data, how it looked last month and see how that worked as well. It also contains some rudimentary indexing that you can do on top of your flat files to improve performance slightly. So, all right, I've done a lot of talking. Let's start looking at some different structures and what we can do with them. So let me see. All right, so again, I've got my data into Azure Synapse. I have my data lake account is here. And I've got files within that. And let's take a look at them within Azure Synapse. And because we're going to look at how we can migrate them and what tools that we can use to do that. So I'm assuming at this point that you have installed your gateway, and this is part of the what am I going to do to make this work. So I've got a step here called integrate. And integrate allows me to build pipelines. And I'll make this bigger so y'all can see it. It allows me to create pipelines so that I can, on a scheduled basis, read my data in. So in my pipelines, what I'm doing here is I've got one that is using a notebook. And this notebook allows me to just use a code that I've created to load my data. So this is using ETL that I've created. So to figure out, it's called Data Load Notebook. And to look at that, I'll look at my Data Load Notebook. And look what I'm doing here is I am reading data and I'm loading it into my data lake and I'm saving it into a table. And I'm doing all of this in a language called Python. Now, this is a way that I can do this. This is the most economical way of doing it. But again, you have to know what you're doing here to be able to access this different kind of development. Now, let me see if I can get this open so I can show you something that is using more data flows. I know I've got a couple of different data flow things that I can show you. While that's loading up, I'll show you another one that I have. In this Synapse account, I have very simple data loads in this one, or very simple data transformations. So again, in integrate, I've got some pipelines. And this is using what is a data flow transformation. So I've got where I'm copying data. I've got a source defined. I've got a sink, which is my destination defined. I'm defining it as a Parquet file. So I'm converting it from CSV to Parquet and doing it that way. Now, if I want to do something more complex, I can say, look at this one. And here, again, this is another Synapse pipeline. And with this one, I'm doing a data flow where I'm doing a flatten of my hierarchy. So you can see here, I'm taking the source, I'm adding columns, and then I'm doing sync. So it's more of a walkthrough process. Like here's another one that I've got where I've got a data flow. And in this data flow, it's got a number of different steps where I am filtering my different inputs. You can see my different inputs here. And then I'm putting them together. So this is more SSRS kind of looking feel because I've got all of my different sources. I am doing some joins to get them together. And then I'm doing some filtering. I'm selecting specific columns. I'm doing that. So this would be the other way of doing a integration where I'm pulling data from a source. And if I have identified where that source is coming from, then that's where I'm going to reference it. So my source, that could be a source that I get because I have created my local integration runtime, and I've created a source, and that source is what I tell it to be. So if I go ahead and open this source, I can just define it how I want. So I can create one that accesses the data that I've got on my local server as well as something that I might have in the cloud, either way. So once I've got my data created, I'm going to probably load it into different areas. And then once I've got it into different areas, then I can start manipulating it around. So I've got, these are my intermediate steps that were created from creating my pipelines. These and within my data lake storage Gen 2 accounts, I've got an archive that I use to migrate data. And here I've got a number of different elements, including raw, and then I have my curated section. So this raw section is data that just drops onto it. And these are the different elements of things that I have. I'm going to take a look specifically at my EMR data, because this is the data that I'm going to show you that I'm going to create a virtual database on top of it. And if I'm like, wonder what the heck this is, I'll just take a look at this. So I just right-clicked on it. It wrote SQL for me, and I can just run it and take a look at my data that I have here. I'm using a SQL statement that it generated for me. So I can see what my different data elements are. With CSV, it doesn't always put the header on there automatically. You have to say, header equals yes to get the header to work out. With Parquet files, it gets a little bit smarter. But I can take the data that I have here. Here's some data that I have that is in a Parquet format. And if I want to look to see what this is, I do the same thing where I'm selecting top 100 rows. This is getting cities data for me. And it just tells me that you've got one record here. It says Seattle. And the population of Seattle is 730,000 people. So just some data that I have there, and I was wondering what I had, and so I can just query it and take a look at it. So this might be your first step for your analysis, and then create a process where I've got my integration, and this can run on a scheduled basis. So I can schedule it to take my data, put it into raw, join it to other elements that I've got, and then create myself a curated area. And that curated area is ready to go for doing any kind of development. And I'm going to show you that I can even connect to it using SQL Server Management Studio. All right. So in order to create this virtual database, I'm going to use Azure Synapse Analytics serverless pools. And these are used to query flat files, as we just saw. It's included as with Azure Synapse. That doesn't cost you more. You don't have to configure anything. It's assuming that you are going to be using the Azure Data Lake Gen 2 account that you created. But if you don't, that's fine. You can add other ones that if you want to connect to those as well. Now you're charged for when you're querying. So if you're not querying, you're not charged. And it's $5 per terabyte. So it's not terrible. And this is what's used for virtual databases. So it's very, very hard, though, to determine exactly how much it's going to cost, because it all depends on how much querying that you decide to do and how complex that is. So what a virtual database is basically like SQL Server in a cloud. And you can do this for very different sizes. And unlike what I have where I just ad hoc took a look at a file, I can, once it's been instantiated as a virtual database or a serverless database, as you will, then I can take that and connect to it through SQL Server Management Studio. And any place where it says SQL Server, I can use that to connect to my database. So let's take a look at it and see how that all works. So what I'm going to do is I actually have SQL Server Management Studio open here. And you'll see that I've got a number of different databases here. Oops. Zoom's not helping me out here. Now it's doing the wrong screen. There we go. All right, so these are the databases that it shows that I have here in Management Studio. So you'll notice all these databases are in this on-demand SQL Azure Synapse.net, and it says it's SQL Server 12. So this is acting just like a SQL Server database, but it's not. So here you can see that I've got some tables. And here are my tables. And these work nearly identically to anything that I might have in a SQL Server database, but it's not. So let's see how I got to this database from a bunch of flat files. So to do that, I'm going to take a look here at my Azure Synapse. And yes, I had to write a little bit of code, but it's not terrible. So first I created a logical database. Let me see if I find. I notice here I've got like the ones that I did have little dots next to them. So it's showing me that I have set those up. So I create, this is my on-demand. So I'm creating once I've got it created, then I can just basically point it to my tables and I say, hey, make sure you put the headers on there. I define what they are, and then it'll do that. Let me find where I've got that loaded. So basically what I'm doing here is I've got my location for this is where my data is. It's in my raw area. I'm going to tell it, and I want how exactly I want it to be formatted. I tell it where you can find it, and then I load it. And this creates this external table. And previously, I created my database initially. So I've got my database living there. And to look at my database, if we look at workspace here, I've got my SQL databases that I created using that same create logical database that I have here. So I'm just creating it, and then they exist here. And then I'll create an external table on top of it, and then see my tables here. And then with that, then once they exist as external tables, then I can use them in SQL Server Management Studio. I can query them within here. They are, in essence, tables. But if I look at where they come from, and they're in my raw area, and if I had to do a whole bunch of different modifications I could have. Just for this purpose of this example, I didn't need to. I'm just taking this data and loading it by telling it how I wanted it defined, and then putting it into my virtual database. And in my virtual database, it acts just like it. So again, you know, it's just a little bit of code that I had to do to make that happen. It basically where I'm just defining it. So I tell it, hey, it's delimited text. Here's my source. I give it the definition and I run it and I'm good. And after that, I'm able to look at it from here within SQL Server or any tool that uses a SQL Server as a possible data connection. So if I wanted to open up Excel and I wanted to connect to this virtual database in Excel, I could do that as well. And you know, any kind of query that I wanted to write, any kind of a join that I wanted to write, it's just like it was a real database, but it's a little slower. So it's not as fast as, of course, having a database. So, but a very relatively simple path to do. And now if you decide this is nice and all, but I want it to go faster, no problem, because you can do something very similar to load your data into a SQL data warehouse using Polybase. And this solution will run you probably $100 a month versus for a comparable SQL Server solution, probably run you $1,600. So it's great proof of concept, great place to try it out, give a database to people. The hardest part is figuring out how to join the data together. But the actual creating this virtual data warehouse part is very simple. And this code is readily available for you to copy. So you don't have to worry about how to write it. So with that, so a couple of caveats. So you want to use curated data. I cannot create a database off of an Excel file directly. I will have to convert it to either a CSV or a Parquet file first. I recommend Parquet files because if you're picking it's basically picking off a list anyway. You use Excel as a source and your speed will improve. It's all about making your queries go faster, and they'll go faster if you take them out of Excel and put them in Parquet. The most challenging thing, again, is knowing how your data is structured so that you can join your data together into a curated area. And once the data is in the lake, then Synapse can use it. And also remember that a virtual database is never going to be as fast as a SQL database, but you may find that it does everything that you need to be able to create a starter data warehouse with data within your organization at a relatively low cost. Because the tools are not going to eat you out of house and home, like say a dedicated tool, which is the data warehouse that'll run you like $3 an hour. So something to think about. All right. Well, I have left a little time for questions. So let me know if you have any questions about anything that I have presented today.
Yes, very cool. So getting some well-deserved kudos there, but that was kind of my question there at the end, right? As we saw that all come together in the pieces, I just wanted to make sure that made sense to everyone, right? So you've reached the no judgment zone, and if we need to discuss, right, we can try and figure that out. So,
Thanks, Peter. But yeah, I mean, like, honestly, the code to make it to persist your data into a database is not that big of a deal. From a structured point, you just basically tell it where it is, what format it is in, and then you just basically persist it. So you can do so much with it. And again, go to Microsoft's and look up Synapse external tables and copy all the code because it's readily available. So, but the harder part is that whole transformation step. Can't get around it. Need to understand how to join things together, and that's never easy. Oh, thanks, Rhonda. Starting the data lake adventure. Yeah. What you really want to make sure of if you're starting a data lake is that you have it well organized, because it's worse than a closet you can't find anything in. So anything that you can do to enforce the rules, like make hard rules and enforce it with, is definitely something that you can do with data security. Making sure that nobody touches the raw stuff. People only write to that area and then they can read whatever they want, just, and you have things named so that you can find things. And if things change, if you have any kind of metadata available, like what the columns mean. If raw source is JSON, would it flatten it in some way, or do we have more native ways of handling JSON? There are you can do JSON a number of different ways. If you want to persist it as JSON, you can. Of course, if you are trying to make it work with tools that are expecting more of a traditional structure, you can do that as well. So you can load up JSON as well as you can CSV, but again, it's that structure thing that you have to deal with. Because I've actually loaded up Cosmos DB with it as well.
Yeah, it's kind of one of those questions where what are the steps along the way, right? And how do you want to plug into it? And that will dictate, right, the paths that you choose there.
Yeah, because JSON's like, it's semi-structured, but it is structured. But you just have records that are all over the place, which means if you're flattening it out so that it behaves more like reporting tools are used to seeing it, you're going to have a lot of blanks and columns, perhaps, if that's how your JSON's structured.
Yeah. Okay,
yeah,
very good.
But yeah, basically the native ways of handling it it's all about how your data is structured, how you want to represent it, and that dictates how much structuring that you will have to do with it.
So it probably might be prudent to remind folks, what are we going to be going over in the third session?
Yes, we're going to be talking about implementing reporting with your data in your data lake. We'll look at a couple of different ways of doing that in Power BI. To access your data, we'll also look at how to access it in paginated reports, should you wish to do that, so that you can see different ways that once your data is in a lake or in a virtual database, what you can do with it once it's there, how you can provide meaning for your data. And I'll also talk about different ways that you could use it, say, in machine learning as well.
Yeah.
SQL Data Partners.